Hey engineers, have you ever heard of the word momentum? Do you know what the word momentum means? Momentum is the measurement of mass in motion. Mass is how much something weighs. So any object that moves has momentum. And people measure momentum by taking mass, how much something weighs, times velocity, how fast something is. So, momentum equals how heavy something is combined with the speed of how fast it's moving. Let's take a look at a couple examples. A semi-truck full of logs has a large mass and must slow down long before a stoplight because even with a small velocity or speed, it has a large momentum and it's difficult to stop. A karate expert can generate enough speed with their fist that the momentum can carry through several bricks, breaking them. If two football players of equal mass or equal weight are traveling towards each other, the one moving with the faster velocity or speed has a greater momentum and will knock the other one backwards. If you've ever watched a building be demolished, you might have seen a wrecking ball doing the destroying. A wrecking ball uses momentum. For a wrecking ball to work, it needs momentum. So it has something heavy, something with a large mass at the bottom, and it's often pulled up or pulled back far enough that it creates velocity or speed. So it's the mixture of how heavy the wrecking ball is and the speed, the velocity of how fast it's traveling that creates the momentum to demolish or knock over whatever it's working against.
This is 9,000 pounds, or more than 4 metric tons of pure heft.
Big old fat crane swinging it in.
Yeah.
So we're going to hit the wall from behind. This is actually a real brick wall. Solid, it's got some supports on the back.
Yeah.
Obviously they'll do nothing against this though.
Our victim, a real American car, isn't it?
Victim number one.
Oh wow, you see the window go?
It's sort of tablecloth whips the window away.
Now the car's just like moving from one place to the other.
What's interesting is that even though the area of impact is, you know, the size of the front of the wrecking ball, it drags in so much extra material, so the dent is like twice the size of it.
Yeah.
It's dragging door and it just bashed the whole car out of frame.
See you later.
Oh, look at that. So you see there where the roof metal is becoming kinked and being like dragged down its crease? It's flinging off all the paint. Look,
Oh wow, that's so
paint's
cool.
chipping off in those lines.
So there's an element of difference to this car
See
Yeah,
what you did with that one?
in the fact that there's no door pillar.
Oh, interesting.
Yeah.
The last one we hit down here, this one,
Yeah.
if we raise the ball maybe a foot, we'll get more sort of crumpleage in the top and less moving of the whole car.
So we're going to completely change the angle of which we hit in the car. So maybe just smash through the top if you
Yeah.
can. All right,
It's
cool.
really, we don't ever really know what's going to happen. We're learning all the time.
It's an experiment.
It's an experiment.
Here it comes. Oh!
Oh, just straight in the window.
That's cool. You see the way the back glass burst? That's
Yeah.
wicked. Look how it's like almost pushing it into the floor now. Dragging it along.
Oh, it's way worse than being T-boned. Look at that. That glass is now just aerial glitter.
I like how the glass is pretty much stationary, but the car is actually being shoved aside faster than the glass is in the floor.
Oh, look at that bend in the tyres in the back there.
Oh, wow.
That's some pressure.
It's so impressive how strong the roof is, the fact that it held on and dragged it.
Well, now we'll just let gravity do the work right on the front.
So the idea is just pull it all the way up, push the emergency release and drop it.
Oh! Oh! That hit the ground so hard, it shook the camera. Look at this camera shake.
Well, like a giant, whoa! Like a giant's footsteps when like in the films when like the dust moves.
If there was a cup of water on the floor, it would have been T-Rex
like
level splat.
like Godzilla style.
Yeah. Look at this GoPro just sat there. We could have killed that GoPro. It's amazing it survived.
£9,000 on a GoPro would do it.
Oh.
Look how the side window burst. It
on the other side?
Yeah, on the other side. It was there 1 second, the next second it just burst. It just exploded.
Excellent.
That went really deep in the car then.
I'm convinced the wrecking ball actually just hit the ground there.
Yeah. Oh, yeah. Oh! So this
Oh, couldn't have been more centered on the engine.
perfect. Whoa, that is destruction. What you got to remember is there's an engine there. There's a solid chunk of metal in the way.
Not mucking about.
Your STEM challenge this week has 2 parts. Number 1, you need to create a wrecking ball. And number 2, you need to create something for the wrecking ball to demolish. Let's take a look at your directions. For the Build a Wrecking Ball STEM challenge, you are to design and construct a wrecking ball and something for it to demolish. The materials you can use are buckets, rocks, yarn, blocks, any type of materials that you think would be useful in your constructing. For my materials, I am going to use some rings, blocks, maybe some yarn, I haven't decided yet, scissors, a bucket, and some rocks. Let's see how it turns out. All right, I am ready to test out my wrecking ball. So I created a little castle-y building for it to demolish, and then I took my bucket, filled it with rocks, put some chain rings up there, and then tied it up to the ceiling. I also, sometimes you'll notice with wrecking balls, they have a chain or a rope that will pull the wrecking ball back so that they can swing it back out with that momentum again. So I have a heavy mass, heavy weight in this bucket. I'm gonna pull it back so that I can have a good velocity, a high speed when it goes crashing into the castle. Let's see if it works. So mine worked, but I still could make modifications. Maybe I want to make a bigger thing to destroy next time. So remember, when you are an engineer, you are going through 5 steps. You plan, you create, you test, you evaluate, and you improve. We are super excited to see your wrecking balls.